So once the action potential has reached the muscle cell or the syncytium, it will go down the T tubules, and then it will stimulate the sarcoplasmic reticulum to release its stores of calcium ions into the sarcoplasm. And then once they're in the sarcoplasm, it will make its way here, which is located within the sarcoplasm. We'll see the thick filament myosin, and we'll see the thin filaments, also known as actin. The calcium ions will bind to the troponin molecules, which will cause the troponin molecules to change shape, and it will actually reveal binding sites for the myosin heads. It actually has receptors for the myosin heads, but they're usually covered. So once the ions come, it'll cause it to change shape, open the binding site, and it will allow for myosin to bind to it. Once it's bound to it, this is an active process, so we need ATP for an actual muscle contraction to happen. So what happens is that all these myosin heads act as an ATPase, meaning that it hydrolyzes ATP for its energy. So once it's binded to the troponin molecules, it can't just pull back on its own. What it has to do is it has to bind with ATP, and it will break up the contents into ADP, adenosine diphosphate, and inorganic phosphate. Once it releases these products, the myosin head will be stimulated, and it has enough energy to release the actin filament and then attach somewhere else. But in this process, it actually pulls it forward, meaning that your muscle actually contracts.